Okay, actually, according to the policy of the university, in this special semester, our class begins at 7:50 a.m. Okay, so we should like 10 minutes before the before 10 minutes to 8. So we start from this time. And for the textbook, we use Hebrews textbook, so dynamics, and Dr. Andrew had made a mistake, I think. So you guys may got the translated version, actually it's in Chinese. So I found this English version, the original English version. That's the 12th edition. So I will ask the Chinese students to send you guys this textbook as well as the solution manual. They will have detailed solution manual for every problems behind each chapter. So it's your responsibility to finish the exercises by yourself. If you have some problem, you just check the solution manual. And by the way, I should first give you the grading policy. Grading policy, which is the most important thing for you. So attendance. %. Every time we'll check your attendance, and according to the laws of the university, if you failed to come here 3 times, you will be out of the course. So be sure that you should attend the. Anyway, if you have some other things to do, you need to tell me and also the teaching officer in advance. Otherwise, I will, regard it as no attendance. Okay, this is 10%, and middle term exam. Middle term exam. This is 40%. 40%. So I will select, say, 5, approximately 5 problem exercises from the exercises, at the end of each section. And as I told you, I have already given you the solution manual. So if you guys don't want to do the exercises, maybe you will fail in this exam. And final term exam, 50%. Okay. So I also told some the Chinese students that if I said that there will be no exam, I worry that nobody will go to study. So definitely I will use exam to actually drive you guys to study. So this is the grading policy. So this semester we started to study dynamics. As I told you, dynamics is much more challenging than statics. And we will go through, I'm not sure how many chapters. 10 or 11 chapters. Oh, by the way, for the we also have this English version in China. You can buy through Taobao or any internet, online shopping. But you can buy the 10th or 12th edition. It's by yourself. The 12th edition is a little different from this original version because in the 12th edition in China, I mean, you can buy it in China. This 12th edition, I'm not sure why the publisher house, deleted 2 chapters. So you may find this is for the English original textbook it's the first chapter is chapter 12, but for the for the Chinese version, you can find that this is chapter 10. So make sure you know that actually because in statics there are 2 chapters are deleted. Also, you can buy the 10th edition, but 10th edition it is with the whole contents. So 10th edition is also from 12th edition, and I think the book is much cheaper in 10th edition. You can buy from Taobao. If international student has some difficulty to buy the hard copy, you can ask maybe Chinese students to help you to buy. And if you are happy to read the electronic version, so I have already sent this electronic version to you guys. Okay, this is the textbook. Be sure to do the exercises to practice, because the middle term exam, final term exams, the problems are all from the exercises, at the end of each section. Okay, so today we started chapter 12. That's the kinematics of particle. Kinematics of particle. Just a particle. Okay. We say that mechanics or engineering mechanics include statics, which you have studied. I hope that you have very you have done well in this statics. So statics deals with equilibrium of particles and also structures, but no time and no motion. And this semester we study dynamics. Dynamics, which deals with acceleration of our body. Acceleration. Or accelerated motion, sorry. Accelerated motion of a body. This body can either be a particle which it has some mass, but the size of the object can be ignited. We call this a particle. Can either be a particle or rigid body. Rigid body. Rigid body is more difficult to treat, in the motion. So first we will study particle. Dynamics studies accelerated motion of our body, and it includes 2 parts. The first part is kinematics. And the second part is dynamics. Dynamic kinematics and kinetics. So in Chinese, I hope you guys know some Chinese characters. In Chinese, we translated this term into this to be, and this also in the same Chinese terms. I'm not sure why they translate both dynamics and kinematics in the same Chinese characters. Okay, so kinematics deals with the geometry of motion. Actually, we from the geometric point of view to study motion. And for kinetics, we deal with force. So force drives the particle or body to accelerate. But for kinematics, you just deal with velocity, acceleration, with from the geometric point of view. So you need the knowledge from statics, such as how to add the velocity, using parallelogram theorem or triangular theorem. This is kinematics and kinetics. Okay, so the first chapter, that's chapter 12, the objective. We just go through this objectives quickly. So the objectives of this chapter to introduce the concept of position, displacement, velocity, and acceleration. This is the basic or fundamental terms of the chapter. And the second objective is to study particles motion along a straight line. This is the easiest case. You just along a straight line. And the third is to investigate particle motion along a curved path using different coordinate system, either from Cartesian coordinates or from the natural coordinates with in curves. And third, to present an analysis of dependent motion of two particles, some two particles relative motion of these two particles. And finally, to examine the principle of relative motion of two particles using translation axis. And the difficulties you will find in the third and the last objective. I hope that you guys have a good performance in calculus. I remember that maybe 1 year ago, I told you that without the calculus, definitely you will not you cannot go through the university study, college study. So you will, maybe this is time to check if you have been studying calculus, having calculus, or to check your performance in calculus. Especially you will find that this in curved path, and also some these principles of relative motion. Okay, so first the introduction, as I have already introduced that mechanics, statics, and dynamics. So you guys to go through this section by yourself. Okay, so we just go to the main point of the first objective. That's the rectilinear kinematics. Rectilinear means that the motion should be along a straight line. So we call this rectilinear. Rectilinear kinematics. First, we study continuous motion. Okay, and some terms. First, position. Rectilinear, so the particle moves just along a straight line. Say we should first, so we should construct a coordinate system. I think it is very, you will construct this coordinates naturally, through this one axis, say x-axis. This is the coordinate system. It's very natural for you to construct this, axis. And this is the original point. So if the particle is in somewhere, along the axis, so you are happy to draw a vector. This vector, starts from the original point of the x-axis and points to the position of the particle. We call this the position vector. So we use the position vector. Oh, by the way, since this is vector, you should use the vector sign over, over R. This is the position vector. Be sure use this vector sign. This position vector specifies the location of the particle at any given instance. Say at the time t, this particle locates at this position, so you use R, and maybe next time the particle moves to another place, and you use R prime. This is t, and t plus delta t. So after a short time, the particle moves. So we use this method to describe the position. And since the particle is moves in a line, so it's actually more convenient for us to use a scalar. S to designate or to show the position. S, it has positive or negative. Here we draw this distance to be S. This is, say, the original position. And if the particle moves to the right direction, S is plus, positive. Positive means that from relative to the previous position, it is at the right. And negative means left. So negative moves left. and the positive moves to right. Oh, sorry. Maybe in our textbook, the author use S to be from the original point. From the original point, it's much clear. Say this is use S. S is a scalar. Scalar from the original point. And next time we use S prime. S prime is defined as the same manner as S. So in this case, you can do the algebraic plus or minus S prime minus S. This is delta S. So if delta S is larger than 0, which means the particle moves to the right, and delta S less than them move to the left. We may a little scared of the vector, but for scalar it's much easier. So in rectilinear, so you can just use the scalar to define the position of the rectilinear motion. We sometimes call the delta S the distance. So distance delta S to be the absolute value of delta S to be the distance, because distance is definitely positive. So we call distance is the absolute value of delta S. Delta S can be either negative or positive. And for delta S is positive, so about positive. By the way, here I also use this sign. You know, the sign to represent the magnitude of R. So actually, from the definition, we know that we can see that this value is equal to the absolute value of S. This is the magnitude of vector. Magnitude of the vector. In one dimension, it's easy. And in later you will see how to calculate the magnitude of vector in three-dimensional space. Okay, so this is the position and displacement. This is the key terms. So definitely you should know what is a position, what is a displacement. Displacement, we use delta R with the arrow sign, delta R, which is defined as R prime minus R. R prime minus R. For rectilinear, it's trivial, but for, say, curved motion, so this is R. R is from the original point of the coordinate system, this particle at some time, and the particle move after, say, delta t time duration, it moves another place, and this is R prime according to our system, and this is the displacement according to the definition. This is the displacement delta R. That's the displacement and with this introduce of the displacement, next we talk about the velocity. Velocity. Sometimes this tablet has some problem, I'm not sure. It's velocity. Velocity. So first we use V. Be careful that velocity also is a vector, so you need to add a vector sign. V average is defined as the displacement delta R over delta T. Definition. So average. And we take the limit as delta T goes to 0. So you will obtain the instantaneous velocity at time t. Take the limit. This is the first, in the first term, you know this limit sign. So delta t goes to 0. Delta, and this is the actual definition of limit. So that's derivative of the position r with respect to time t. Or r is a function of time t. So if we think that r is continuous enough, you can make the derivative. Very important definition. And as I told you, for rectilinear, we actually use the scalar s to design or to represent the position. So actually, in rectilinear, the velocity, the velocity along this line can be either positive. Here, this is positive, and goes the left, this is negative. So actually, in rectilinear motion, you just use the scalar v to define the velocity. And if v is positive, which means that the particle goes to the right position, and negative, the particle goes to the left position. So we actually simplify the vector form into a scalar form. So it's convenient for us to treat in scalar form. Okay, so this is the rectilinear version of the velocity. And unit in SI unit system, the velocity is meter per second. According to the definition, the dimension of delta r or dr, this is in meters and this is in seconds. So you will obtain the units meters over seconds. This is the unit. Important term, velocity. And the last term, acceleration. So in this path, the particle at time t, the particle here at time t, we just use time t. Time t, the particle here, so it has some velocity vt, and in another time, the t prime, the velocity v prime at time t prime. So you will find also maybe in some motion, the velocity of the particle also varies. So we need a term to describe this variation. We use the acceleration. So first, the average acceleration defines in the similar manner as the velocity. That's the velocity difference over time t. The velocity difference is v prime minus v. Be sure that you put the vector sign on every vector and delta t, and also take the delta t to be 0. So delta t goes to infinitesimal. So you will obtain the instantaneous acceleration. That's the limit. Delta t goes 0. And the delta v over delta t. And this is the definition of limits. So that's the derivative of v with regard to time t. Definition of acceleration. In rectilinear motion, you can represent A as S. So I dropped the vector sign, fixed sign off, because in rectilinear, you just use negative or positive to represent the direction. Rectilinear motion. You take a scalar A. So A is dv dt, because in rectilinear you also use this scalar v, and here you take the derivative of v with respect to time. And we know that dv is ds over dt. So you take this derivative with respect to time again. So you will obtain ds, second derivative with respect to time. And this is also from the vector form. This actually is d second derivative vector, position vector with respect to time. And if A, for the rectilinear motion, if A is positive, we call this as accelerating. And A negative, decelerating. And if A is 0, this is the case of constant velocity. The velocity, doesn't make any change. This constant velocity A. Okay, in rectilinear motion, we also sometimes use the following equation to solve some problems. It's maybe more convenient. So we'll derive this equation for you. As I told you, for rectilinear motion, v can be regarded as the time derivative of this displacement. By the way, s is also, in rectilinear. Just assign the scalar and a as the time derivative of v. Okay, so we just take dt to be, from this equation, dt is ds over v. And from the second equation, dt is dv over a. Since, both are dt, they are certainly equal to each other. So you will find an interesting equation. That's a times ds equals v times dv. This formula sometimes is more convenient in solving some problem if you have no information of time. You just use a and the displacement, velocity, the variation of velocity to obtain the solution without any knowledge of t. Okay, this is convenient tools for us to use. In maybe later you will see in some examples. Okay, here also for constant velocity, I added some comments for constant acceleration, not velocity, sorry. Constant acceleration. Here the acceleration is a constant. We denote it as a constant. So in this case, for rectilinear motion, this is dt over dv over dt. So dv is equal to ac. This is a constant, and dt, and you make the integral. So integrating this differential form from the initial velocity to velocity v at this time, and dv integrating the right hand side term from time 0, this at initial time 0, to t and ac dt. Since this is a constant, you can take it out of this integrate take this AC out of this integration, and you obtain V minus V0 is AC times T, or you obtain the velocity at any time is equal to the initial velocity plus AC times T. This is the result for velocity when the acceleration is a constant. I think you guys have some knowledge from physics. Maybe even in high school, you know this formula for constant acceleration. But here we just from the point of from calculus point of view to derive this equation. Maybe in high school, the teacher just gave this result to you. So with the powerful tool calculus, you can derive the result by yourself. Okay, this is the velocity. And next we will derive the expression of displacement for rectilinear motion with constant acceleration. So the procedures are similar. So first, you need to use start from this formula. We know that V is ds over dt, so that's V0 plus a constant t, and you obtain the differential form ds equal to V0 at AC t times dt, and you make this integration. So from S0, that's the initial position or initial displacement, to 0, ds should be equal to 0 from time 0 t, and V0 at AC t dt. And here the left hand side, that's S minus S0, and the right hand side, you after integration, V0 is a constant, so that's V0 t minus 0. And for this term, the antiderivative, this is very easy calculation. The result from calculus. The antiderivative of this term is 1/2 AC is constant and t squared from 0 to t. Yes. Okay. So we just reform this equation into S is S0 plus V0 t plus 1/2 AC t squared. This is two special formulas, two special equations for the acceleration with constant acceleration. Another useful formula is velocity. Be careful. This is only for constant acceleration. You just can't. You cannot use the for other cases. Just a constant acceleration in rectilinear motion. But the next equation is general, so it can be used in any case. This equation is velocity as a function of position. We started from this equation, so I just start from here. You make the integration. So make the integration. You will obtain S from S0 to S a ds equal to velocity from V0 to V dV. And in the special case for constant, we can obtain this, this, just let me to equal, this is equal to 1/2 V square minus V0 square. Because this antiderivative of this term is 1/2 V square. So you insert the 2 ends, that's V0 and V, you obtain this result. And this equation is for all cases, but especially for the constant acceleration circumstance. So if A is a constant, so you can also make out this integration. In this case, left hand side is AC. That's S minus S0. This is 1/2 V minus V0. So you will obtain this result. V0 square is, V square is V0 square plus 2 times AC times this displacement. This is also for constant velocity. Oh, by the way, we just take our time break just one time. So I will continue my lecture. So we start this introduction for the knowledge of rectilinear motion and also the velocity, acceleration. We can make some exercises. So example one, I just show you. Oh, by the way, there are also sometimes called the speed. By the way, here I make some comment of the speed. Speed. We have studied the velocity. Actually, velocity is a vector. A speed is a scalar. There are some differences. Speed defined as the path length as shown here. Speed. Say if a particle P moves to the right and then turn its back to the left, so the total length of the path shown here is st, and the speed actually is defined as the total length st over delta t. So it's different from the velocity. But anyway, maybe speed is not. Will not you will not encounter speed in the later, but just here to point that the difference of speed and velocity. Velocity, is the difference of position over time dt. Okay, so we are moving to the examples. So for rectilinear, actually it's easier for you guys to solve. Maybe in the middle term, I will give some easy problems in rectilinear for you to solve. So the important point when you are trying to solve rectilinear motion, from the introduction, we know that dynamics concerns with body that has accelerated motion. Kinematics is a study of geometry of the motion. Kinetics is a study of force that causes the motion. And rectilinear kinematics refer to straight line motion. Speed refer to magnitude of velocity, average. Speed, total distance traveled divided by the total time, and particle that's slowing down this deceleration. This is also very common sense to you guys. Particles that has acceleration, it has zero velocity, can have acceleration, at the same time zero velocity. Say from the stationary stationary from the stationary original position. If the particle is stationary, so it have zero velocity, but it can have the acceleration, so it accelerates. The relationship, this is convenient for some problem without knowledge of time t, and this is some basic definition from of acceleration and this velocity. Okay, so the procedures for solving a problem. First, you need to establish a coordinate. So otherwise, I don't know where is the the original point and what is the position. So first, you should you should answer try to construct a coordinate system with a fixed origin and the positive direction for rectilinear motion. And for rectilinear motion, you can use sign the scalar s, v, and a to represent the vectors. We call this is the algebraic signs with algebraic sign. This algebraic signs actually defines the vector. Oh, sorry, the direction. We know that for vector, it has the magnitude and also the direction. And positive sense of this scalar, as I have already explained. Okay, so the first example, a car in this figure moves in a straight line, so that's a rectilinear motion, such that for a shorter time the velocity defined as v equals 3 times t squared plus 2 times t foot per second. T is in seconds, so ask you determine the position and acceleration when time is 3 seconds. I also should give you the initial condition t. So when t is 0, the displacement is 0. So as according to the procedures, you need a or be sure to do the exercises by yourself. You need to practice. Sometimes, if you just listen to my lecture or study, or you just look through the book, you will have this imagine that you actually you know everything from the book, but once you try to solve some problems, you will have this kind of that kind of problems or difficulties. So be sure you make enough practice. Coordinate system. So the position extends from the initial point, and the positive direction is to the right. This is the coordinate system. And first, you needed to solve the velocity in order to obtain the displacement. And according to the definition, velocity is time derivative of the displacement s, and the velocity is given in this problem, in this example. So you make the integration. This is very this all the fundamental calculus. If you even have the problem or difficulty in solving this kind of integration, make sure to study calculus again by yourself. And s, so antiderivative s, antiderivative t cube, t square. So you add you substitute from the initial to the present time to obtain the displacement s. and you substitute the time t is 3 seconds, so you obtain the displacement. We also need to solve the acceleration. So acceleration is actually the derivative of velocity. Displacement, integration, and acceleration is derivative. So you make this derivative and substitute time t. Very easy example. I will set, maybe 2 or 3 problems in the middle term with this kind of easy problems to let you to pass. But if you have no idea of the calculus and also dynamics, definitely you will fail the exams. Okay, the second example, a small projectile is fired vertically down into a fluid with the initial velocity, and due to the drag resistance, the acceleration has this form. Where v is the velocity. This is actually quite common, in fluid. You can see that the acceleration is proportional to v actually cube. This is, the author has a very back knowledge actually from fluid mechanics. In the following semester, I think you guys will also learn fluid mechanics. Actually, fluid mechanics, especially in liquid, the damping or the friction is very high. You can see that this is proportional to v square. This is why some, say, submarine cannot go faster in the fluid. You say if you increase the velocity to be 2 times, you will find that the viscosity or the drag force increased to 8 times. Okay, so but from this dynamics course, we are not deal with fluid mechanics. So we just focus on the velocity and the acceleration. So I told you this equation of acceleration. That's this formula, and you are asked to determine the project velocity. So velocity, definitely you needed to know that a is dv over dt. So from this expression you can obtain v, right? So you move this dt to the right hand side and make the integration. And the antiderivative of 1 over v square is minus 1/2 1 over 2 1 over v square. Okay, this is the antiderivatives, and you insert the low and the upper limits, and this integration is easy. T, that's just t. So you obtain the velocity expression v with time t. This is the expression, and you insert the time t is 4, so you obtain the velocity. And if you put the answer, here, I know that you are quite friendly to the teachers, because I can find your answer easily through your answer sheet and make the corrections, give you the grades. Okay, so we are also asked to calculate the position. So position, you should first to write this equation and this differential form, and make the integrations to obtain s as the function of time t, and insert the time t is 4, so you obtain the answer. It's easy questions, easy problems. Okay, let's stop here. Just have a short break.